Hey everyone, welcome to lesson 1.5. Today we're going to be talking about exponents. So that's our goal today, is to work with exponents. So let's take a look at our aim. Our aim says, I can multiply algebraic expressions using properties of exponents. So we're going to talk about multiplication and using exponents. Let's read. We've used exponents a little so far, but they will become much more important to us as our studies in algebra progress. So, in the next few lessons, we are going to work with some basic exponents. Recall that an exponent is a way to indicate repeated multiplication by the same number. So if we look at the box where it says exponents is repeated multiplication, the definition says that if n is a positive integer, like 1, 2, or 3, then x raised to the n power is going to be x multiplied that many times. Okay, so that's a really confusing definition when it's all in letters like that. So I think the best way to think of this is to think about examples. So let's take a look at A. Exercise 1, write out what each of the following exponent means as an extended product. Extended product, the word extended means you take something and make it longer, right? If I extend something, I make it longer. So extend means to make longer. Right? So for letter A, let me change the color of my pen. Letter A says 2 to the 4th power. That's the same thing as saying 2, how many multiplied 4 times. 2 times 2 times 2 times 2. That's what that little 4 means, that I multiply it 4 times. How about letter B? 3 to the 2nd power. 3 to the 2nd power is going to be 3 times 3. I do it 2 times. And how about letter C? Letter C is 5 to the 3rd power, so that's 5 times 5 times 5. Now if we take a look, the rest of the directions of this exercise say what? Then find its value. So I've done all the extensions, but now I have to find the value of these. So let's take a look at A. 2 times 2 is 4 times 2 times 2, which is 4 times 4, which is 16. How about letter B? Letter B says 3 times 3, easy, 9. And finally, letter C, 5 times 5 times 5, well, let's do this, the first two 5s is 25 times 5, and 25 times 5, if you put that in your calculator, or if you think of 25 5 times, you get 125. So this is what extending a product is. Exercise 2. Write out what each of the following terms involving exponent means as an extended product, so we're extending again. Carefully consider your order of operations and remember that exponents come before multiplication. So in this exercise, we don't need to find a value. So we're not finding value. We're just extending the product. So let's take a look at A. A says x to the 3rd power. What does that mean? It means we're multiplying x 3 times. Okay? X is being multiplied 3 times. How about letter B? How many x's do we have? We have 2 x's, so 1, 2. And how many y's? 4. So times y, times y, times y, times y. That's a multiplication sign. Letter C is a little trickier because we have parentheses. This parentheses is saying that this 2, this whole thing is being raised to the 2nd power. So it's like saying 2x times 2x. Now when we extend something with numbers, we want to make sure all the numbers go in front. So I'm going to regroup these 2's and put the 2's in front and the x's at the end. Do I still have 2 squared? Yep, 2 times 2. Do I still have x squared? Yep, x times x. I just reordered it so the numbers go in front. Letter D is 4x to the 4th times y to the 3rd. Something to keep in mind, when you see all of these things pressed up next to each other without any symbols, like I don't see a plus sign, minus sign, multiplication sign, this means multiplication when all of them are pressed up together like that. So this is like saying 4 times how many x's? 1, 2, 3, 4. And how many y's are there? 3. 1, 2, 3 y's. And that's my extension. Letter E, this also has parentheses. If we take a look at E, E is very similar to C. It's got that parentheses, except instead of being raised to the second power, what am I raising it to? The third power. So this is like saying 9x squared times 9x squared times 9x squared. I'm raising 9x squared to the third power. But I haven't extended it yet. I still have some x squareds I need to get rid of. So I'm going to say this is like 9 times 9 times 9, with all the numbers in front, times x squared times x squared times x squared. Now extension, let me pick a different color. An extension means there are no exponents. So I still see exponents in problem E, so I've got to get rid of them. I'm going to keep the 9 times 9 times 9, but each of these x squareds breaks up into how many x's? 2. So I've got times x times x, times x times x, times finally x times x. So I've got 6 x's, and that's my final extension. Finally, F. Now be careful, F has parentheses, but it's also got this negative. So I'm going to say here, watch your signs. And I'm going to say that a lot in videos because signs are really important. So this is the same as saying negative 4x to the third times negative 4x to the third. I'm raising that to the second power, so I need 2 of them. Now I can use my grouping properties and drop the parentheses. Okay. Put my numbers in front, so negative 4 times negative 4. Times x cubed times x cubed. And I have to get rid of these exponents, so I'm going to keep the negative 4's. And I've got 3 x's in the first one, and then 3 x's in the second one. So this is extending a product, right? You're getting rid of your exponents and you're extending all of these products. Okay? Good habit to box your final answers. These are your extensions. Okay? Alright, let's take a look at exercise 3. One of the nice aspects of exponents is that they follow very predictable patterns. Patterns are great in math. It's something that you can see over and over again and it won't change. These patterns are known as exponent rules, and they do absolutely rule. They're very helpful and they help us do exponents quickly without having to make an extension. Let's figure out the simplest one in the next exercise. So exercise 3 says, write out each of the following products. So write out each of the products, then express them in this form. This form is like saying x to a power, right? They just want one simple form with x. See how each of A, B, and C has 2 x's? They want you to combine it into just having 1 x. So the first thing we're going to do is extend it. So for A, I have 2 x's, and then I have 3 x's. How many x's do I have? I have 1, 2, 3, 4, 5. So I can write this as x to the 5th. For B, I have x to the 5th times x squared. How many x's do I have? I have 1, 2, 3, 4, 5, and I have 2. So 1, 2. How many x's do I have? 1, 2, 3, 4, 5, 6, 7. So this becomes, x to the 7th power. Can you try letter C on your own? Pause the video and try letter C. Okay, for letter C, you should have gotten x to the 8th. I've got 4 x's in the first part, 4 x's in the second part, so that's a total of 8 x's. Now, there's an easier way to do this. We should be able to see a pattern here. What is that pattern? Right? What's that pattern? Can you give a generic rule for what happens when we multiply 2 terms that have the same base? Now notice, if we go back to these problems, see how A, B, and C all have the same base of x? That's important. This only works if they have the same base. So exponent rule number 1 says, if I have x some base to raise to a power times the same base raised to the power, I can have that base and add the exponents together. For an example of this, let's say I have x to the 3rd times x squared. That's like saying x to the 3 plus 2 is x to the 5th. I am adding the exponents, right? It's adding. This exponent rule allows us to multiply large powers of variables without actually having to write out the products, like where we had to extend it. Make sure to internalize this rule. Internalize means memorize. Memorize this rule. In other words, think about it until you're absolutely sure you understand why it works. Eventually, we'll extend exponent rules to weird situations with all sorts of exponents. So we're going to start off simply, but we're going to get good at it. So exercise 5 says, quickly write each of the following products as a variable raised to a single power. So let's take a look at A. A says x to the 4th times x to the 9th. Well, if I use my exponent rule number 1, I can say this is the same thing as x to the 4th plus 9, and 4 plus 9 is 13. So I could find this answer without having to write out 4x's and 9x's. Saves a lot of time. How about B? B is like saying x to the 2nd power plus the 3rd power plus the 4th power. It's okay if you just keep adding on and tacking them on. It's not just, you don't just have 2, you could have 3 or 4. So now we add, this is like x to the 5 plus 4, which is x to the 9th. Can you try y on your own? Pause and try on your own, please. Okay, you should get y to the 2 plus 6, which gives you y to the 8. It's okay if the variable's not x. You're going to see lots of different variables. So it won't always be x. It could be y, m, whatever letter they want to use. Okay? Finally, let's take a look at exercise 6 and 7. Often you will need to be able to multiply more complicated terms and write them in a convenient, simplest form as possible. This next exercise walks us how to do this and the laws and properties needed. So, like in the previous lesson, we've learned two properties. We've learned the associative property and we've learned the commutative property. Now we're learning this third one, this exponent property. So thinking of those three properties, let's take a look at exercise number 6. The steps to simplifying this product, 5x cubed times 2x to the 7th, the simplest terms are shown below. Write what justifies each step. So let's take a look at step number 1. Step number 1 starts off with the original problem. So there's 5x to the 3rd times 2x to the 7th. What did they do to go from here to here? Well, they just took the 5 and the 2 and they rearranged it. So they changed the order. What property changes the order? That would be the commutative property. And are we adding or subtracting here? Are we adding or multiplying here? We're multiplying, so this is a commutative property of multiplication. Okay? Now let's take a look at the second step. The second step took this right here, the reordered one, and what did they do to get to here? Well, they used parentheses, which is grouping symbols. So they grouped, and what's the property for grouping? The associative property. I like to remember associative property by saying I associate with certain people. So when I associate with certain people, I group myself with them. So that kind of helps to remember that associative means I'm grouping. Finally, in step 3, what's happening? They are going from the grouping to what? What do they use to get this x to the 10th and the 5 times 2? Well, they use that exponent rule 1 that we just learned, where you have x to the a times x to the b, so you get x to the a plus b. So look, they took x to the 3rd plus x times x to the 7th and got 3 plus 7 to get 10. So they used that new property we just learned. So this is justifying. So again, these are laws you need to memorize and feel comfortable using, and you should have these on your vocabulary cards. Finally, let's move on to the last section. Each step, I'm right here, Each step in an algebraic manipulation can ultimately be justified, meaning explained, using a property that was established about numbers, like the commutative, or a pattern like exponent rule above. But we also need to become fluent. Fluent means good at, right? We need to become very good at these manipulations. This next exercise gives us the opportunity to work with that. So let's take a look at exercise 7. Exercise 7 says, rewrite each of the following as equivalent expressions. Equivalent means the same, like you're simplifying it to something simpler. So this is like saying simplify, and we've worked with equivalent in previous lessons. Okay, so let's take a look at A. A says 2x to the 7th times 8x to the 5th. Well, I'm going to regroup the numbers, so I'm just putting the 2 and the 8 in front, and then the x to the 7th and the x to the 5th at the end. Now I'm going to multiply. 2 times 8 is 16, and when I multiply these exponents, it's like adding them. So I get x to the 7th plus 5, and so I keep the 16 and get x to the 13th power. Okay, so it's a lot like what we did up here in this exercise, where they changed the order, they grouped them, and then they did the multiplication. I'd really like for you guys to try B and C on your own. Give it a shot. So pause the video, try B and C on your own, and then check your work when you come back to the video. Okay, welcome back. For letter B, you should have negative 4x to the cubed, x to the 3rd power, times 2x squared. So I just dropped the grouping symbols. Now I'm going to reorder and put the negative 4 and the 2 in front, and the x to the 3rd times the x squared at the end. I'm going to multiply now. Negative 4 times 2 is negative 8, and then the exponents are added together, 3 plus 2, and I get negative 8x to the 5th power. Letter C. Now this one's a little trickier. When you have parentheses raised to a power, it's the same as saying whatever is inside raised to that power. So I get negative 6x cubed times another negative 6x cubed. Now I'm going to regroup and put my negative 6's together times the x's together. I'm going to multiply. Negative 6 times negative 6 is a positive 36. Remember, 2 negatives make a positive. And this becomes x to the 3 plus 3. So I get 36x to the 6th power. Okay? Now remember, when you watch these videos, you can always go back, you can rewind, you can pause, and in class you can come ask me questions, Ms. Samaru questions, Ms. Vasquez questions, if you're still unsure. Okay, good luck on your fluency, and I will see you in lesson 1.6.